Okay, so with functions, we're going to look at um, what y value goes with the corresponding x value. So just referring to briefly to the definition, a function itself is when each x has a unique y. Now, what we're going to use it for is we're going to use it as if I take a value of x and I stick it into a function, I get a y value out. So, for example, on this first one, f of negative 1. So f of negative 1 simply means replace x with negative 1 and just simplify out the operations. And this is a pretty common task you'll do in calculus. So negative 1 squared is positive 1. Negative times a negative 1 is also positive 1, and then plus 2, and that gives us 4. Okay. We'll do it with fractions. Fractions come up a lot in calculus, so we got to feel very comfortable with this. So 3/2 squared minus 3/2 plus 2. And that would be 9. See, 3/2 squared is 9/4 minus 3/2 plus 2. And then I'm going to convert everything to a common denominator in terms of force. So 9/4 stays the same. 3/2, if I double everything, I get 6/4. And then 2, in terms of force, I need a fraction that reduces down to 2, and that would be 8/4. And then I can just focus in on the numerators. I'm sorry, let me do that again. 8/4, I wrote 8/2. Probably want 8/4. Okay, so I know the final answer is going to be in terms of force. I can't quite see that. Let me scroll down a little bit. Okay, so what I need 9 plus 8 is 17 minus 6 is 11. So 11/4 for that one. Okay, so number 3 is in Algebra 2 or in college algebra, we learned about a process called a difference quotient. And so this came up again in pre-cal. And prior, in those two situations, it was just a formula process that we used. The first unit in calculus, you actually will do something with this. So it'd be very nice if we refreshed how to actually find the difference quotient. So I want to do 3 things here. I'm going to evaluate f of x plus h. So that would be x plus h squared minus x plus h plus 2. Alright, so with f of x plus h, I'm going to square the first 2 terms, which would be x squared plus 2hx plus h squared. I'm going to distribute the minus in to the next term, so that'd be minus x minus h plus 2. Then, going back to, so that's the first part of our little formula there. The second part of our formula is subtract off minus f of x. So I'm going to bring down the initial function, which is x squared minus x plus 2. And I'm going to literally just subtract these two from each other. And then notice that only certain terms are going to cancel out. So the x squared cancels out with the x squared. Let's see, the minus x cancels out with the minus x. And the plus 2 cancels out with the plus 2. And I'm literally left with 2hx plus h squared minus h. And so the third thing I'm going to do is divide by h, which gives me 2x plus h minus 1. You get the 2hx, divide that, but you get 2x. H squared divided by h gives us the plus h, and the minus h divided by h gives us the minus 1. Okay, and so for right now, that's pretty much all we're concerned about with difference quotient, is just getting that expression. In the first couple of days of your calculus class, you'll find out more about this statement, and you'll definitely do a lot more with it. Okay, so with this next example of a function, we're going to look at a rational function and then doing function notation within it. In other words, we've got lots of fractions floating around. This first one, number 4 here, is asking us to evaluate it at -4 and evaluate it at 2 and then add those two together. That one's pretty straightforward. So I want f of -4, which is 2 times -4 over -4 plus 1. And that'd be -8 over -3, which is 8/3. Okay, then I want f of 2, which is 2 times 2 over 2 plus 1, which also works out to be, well, not also, but you get 4 on top and you get a 3 on the bottom. So I want to add those two together. So I want 8/3 plus 4/3, which is 12/3. And of course, 12/3 reduces down to 4. So there is that. Okay, number 5, we want to evaluate that at -1/2. So that's 2 times the -1/2 over -1/2 plus 1. Well, 2 times the -1/2 is -1, and the -1/2 plus 1 is just 1/2. And then if you remember your complex fraction rules, if you're dividing by a fraction, you multiply by its reciprocal. So this would be -1 times 2 over 1, which works out to be -2. Okay. And this last one, number 6, this is another form of difference quotient that may or may not have come up in prior classes for you, but in calculus you definitely will use this form, or at least they'll refer to it a few times. So it'd be nice if we do a little bit of practice with the algebraic manipulation on this. So I want f of x plus h Okay, so this last example is another illustration of the difference quotient. It's not a commonly used one, but it is something that you will encounter in calculus. And so before I even jump in and get started, I want to try to do a little motivational thing here. How good is your math endurance? This particular problem is going to look very scary, and it's going to look that way because we're dealing with fractions inside fractions. And then on top of that, it's just a longer problem. It's going to take us a couple more minutes than the other problems have done. So as we get going, just take a deep breath, and if you need to look away from the screen or pause it and just kind of question life, that's perfectly fine. We will get through this problem. Be patient, please. Okay, and I'm going to start by doing this a little differently than the last difference quotient one, and simply meaning I'm going to just, well, you'll see in a second. I'm going to set it up as a complex fraction. So f of x plus h would be 2, would be 2 x plus h, 2 times x plus h over x plus h plus 1. And then minus f of x minus h would be 2x minus h over x minus h plus 1. And then I'm going to divide that by 2h. So instead of doing this in smaller steps, I'm essentially doing this as just one giant problem, and you can kind of see that I've got this big common denominator concern that's come up. And so the next thing I'm going to do is I'm going to write down my common denominator. And it's going to be a little unpleasant, but that's okay. We're going to get through it. I've got three fractions, believe it or not, that I'm staring at. And I'm going to make a list of all the denominators. One denominator I see everything has in common is the 2h. So I'm going to write it. Then I see in the numerator, this top first fraction here has a denominator of x plus h plus 1. So I'm going to write it. And then the other fraction is the denominator of x minus h plus 1. Okay. So when I work this out, the common denominator has to have those three elements in it. Okay. And then as far as simplification goes, I'm going to multiply each fraction by whatever's missing from that common denominator, and that should allow me to combine like terms and that sort of thing. So if I take the 2x plus h, well, what was missing from that fraction? That fraction had a 2h, because everything has a 2h in it. This fraction has an x plus h plus 1, but what it doesn't have is it doesn't have an x minus h plus 1. So I'm going to multiply by it. And then I'm going to bring down the 2x minus h. And what was that second fraction missing? Well, it had a 2h, because everything has the common denominator of 2h. It has an x minus h plus 1, but it's missing the x plus h plus 1. So I'm going to bring down it. Okay. Now, I'm going to take advantage of some extra space we have down here at the bottom, is we're going to do some giant multiplication, simplification type thing, because my next step of this process is to simplify that numerator, and I notice there's a lot of multiplying I can do. I know the denominator I can just bring down, so I know that's not going to change. Helps if I write it correctly. X plus h plus 1 and x minus h plus 1. Okay. Now over to the side here, and I'm going to just switch colors to emphasize this. I want to know, for starters, what is 2 times x plus h hold on. 2 times x plus h times x minus h plus 1. I just want to know what that is. And then we'll do the other half here in a second. So already I'm going to distribute the 2 in. So that's 2x plus 2h, x minus h plus 1. And then I'm going to distribute in each term. So 2x times x is 2x squared. 2x minus h is 2hx. And 2x times 1 is 2x. And then the second term, 2h times x is plus 2hx. This would be minus 2h squared. Now notice I'm offsetting where I'm writing these things at, so sort of combining like terms ahead of time. 2h times 1 is plus 2h. And so when I group all of this together, I get 2x squared. The 2hx's cancel out. Plus 2x minus 2h squared plus 2h. So I can bring this part over, as that's going to be 2x squared plus 2x minus 2h squared plus 2h, and then minus something. And so I got to come over here, and I'm going to do this in red because they're going to look very similar to each other. I want 2 times x minus h times x plus h plus 1. So distribute the 2 in. So 2x minus 2h, x plus h plus 1. And then I'm going to use the same sort of organizational trick. Distribute the 2x in first. So that's 2x squared plus 2hx plus 2x. And then distribute the minus 2h in, and then line up like terms as I go. So that's minus 2hx minus 2h squared plus minus 2h. Okay, so that simplifies down to 2x squared. The two hx's cancel out, plus 2x minus 2h squared minus 2h. And so that's what I'm going to copy over here. So 2x squared plus 2x minus 2h squared minus 2h. Okay. All right. Let me go back to blue. So denominator I'm going to keep the same. For now, it's going to change in a second. All right. Now, what survives of this numerator? So I'm subtracting these two things off each other, so that's going to change some signs. So like, for example, the 2x squareds, they cancel out. 2x squared minus 2x squared means there's no more 2x squareds. The 2x's cancel. All right, so minus 2h squared subtract a negative 2h squared. That's going to cancel out those. And a 2h minus a negative 2h, that gives me 4h. Okay. And so what divides out? Well, I've got a 2h on top, and I've got, 4h on top, and I've got a 2h on bottom. So that would, the 4h and the 2h divide out and leave me with 2. So I have a 2 on top, and then I have the remnants of that denominator of x plus h plus 1 times x minus h plus 1. Okay, and so that would be what our difference quotient simplifies down to.